Today we're going to look at Unit 8, Section 3. We're going to talk about chords, tangents, secants, and in relationship to all three, finding lengths. Let's refresh our memory about what each of these are. A chord is a line segment connecting one point on the circle to another point on the circle. And it doesn't go through the center. So AB is a chord. A secant is a line going through the circle at 2 points. Note there's a line segment, secant's a line. So the secant is line CD. Tangent intersects the circle at a single point, and it's a line, EF. Now, when two chords intersect each other, not only can we figure out the angles like we did previously, we can figure out these angles, but we also can figure out their lengths. There is a unique relationship that exists when two chords intersect each other. The lengths of each chord, when multiplied by each other, equal the other lengths of the chord multiplied. In other words, A times B is equal to C times D. So again, you can multiply the segments of your chord set equal to the other segments of the other chord. So let's look at this example here. So I'm going to take 6 times x, set that equal to 8 times 3. Six x, 8 times 3, divided by 6. 24 divided by 6 is 4. So that's x. Let's look at another example. Or not. Let's look at another concept. When we have two secants intersecting each other. When we have two secants intersecting each other outside of the circle, we have another unique property that exists. The way it works is if you take the outside part of your secant, you can multiply it by the whole. That equals the outside part of the other secant times the whole of the other secant. So outside times whole equals outside times whole. Or some people like to call it ow, outside whole, outside whole. So let's look at an example. Here, I have just letters. We're going to work through the process so we can see what it looks like. So again, it's outside times whole equals outside times whole. Our outside is B. Okay, that's easy. B times the whole is this section plus this section, which is A plus B. A plus B. So B times A plus B equals outside whole of the other secant. Outside whole. So the outside is D. The whole, you add them. C plus D. So outside times the whole. Let's look at an example with numbers. Alright, here we go. Outside hole equals outside hole. Or ow. Outside hole. The outside is 8. The hole is 6 plus 8, 14. So 8 times 14 equals the outside, which is 4, times the hole. The outside is 4. The hole is x plus 4. And I could work it out as x plus 4. I like to make my life a little bit easier. Instead of calling this x plus 4, I'm going to use another variable and call it y. Y represents the full length. So to find x in the end, I just subtract 4 from y. So I say 4y. So let's solve this problem. We're going to do 8 times 14, that equals 4y. So it's 112 equals 4y. Divide by 4. Y equals 28. Remember, y is the full length. I want to know what x is. So the whole thing's 28, but this part is 4. So I subtract. 28 minus 4 is 24. And that's x. Let's look at another example. Here we go. Again, outside times the hole. 5 times the hole. 5 plus 4 is 9. That equals outside times the hole. The outside is 3. The hole is x plus 3. But again, I like working with making my life a little bit easier. I'm going to call it y. So 3 times y. 5 times 9 is 45. 3y. Divide by 3. Y equals 15. Now, just like the previous problem, y is the full length. I want x, which is this part. So I take y, 15, and I subtract 3. 15 minus 3, 12. Now, what if we have a secant and a tangent? Well, a tangent only has one part. Look at this. But it's the same idea. It's the same idea. There's a relationship between this tangent and the secant when it comes to the lengths. The tangent only has this outside part. But the same idea applies. The secant is still outside times hole. Outside times hole. I square this. Outside squared equals outside times hole. O squared equals ow. So you square the tangent. The secant is outside times hole still. Let's look at an example. Here we've got x. So I square it. So it's only the tangent. So I square it. X squared equals the outside times the hole. The outside's 4. The hole, 4 plus 5, is 9. X squared equals 36. So x is the square root of 36, which is 6. Let's look at one more example. Now notice here I've got x down here. Here, it's my tangent. I square the tangent. 5 squared. Outside times the hole. Outside times the hole. The hole is x plus 3. But again, I like making my life simple. I'm going to call it y. 5 squared equals 3y. 5 squared is 25 equals 3y. Divide by 3, and we get 8.3 repeating. But that's y. Y is the full length. I want to know what x is. So I subtract 3. 8.3 repeating, subtract 3, x is 5.3 repeating. And that's the end of our notes.